Now, we're going to take up one more problem on the shaft. The problem number 5, it reads as a hollow circular steel shaft has to transmit 60 kilowatt at 210 rpm such that the maximum shear stress does not exceed 60 meganewton per meter square. If the ratio of internal to external diameter is equal to 3 by 4 and the value of rigidity modulus is 84 GPa, find the dimensions of the shaft and the angle of twist in a length of 3 meters. This problem has been asked several times, maybe it will be asked in 4 times. So here, first we are going to take up the data. The shaft has to transmit 60 kilowatt, so capital N will be equal to 60 kilowatt and small n will be equal to 210 rpm. And the maximum shear stress, which is tau max, will be equal to 60 meganewton per meter square, which will be equal to 60 newton per mm square. So that means here mega is nothing but 10 to the power of 6 newton per meter square. Convert that meter square into mm square, so that divided by again 10 to the power of 6. So therefore 10 to the power of 6 and 10 to the power of 6 gets cancels. So it will going to become 60 newton per mm square. So therefore the ratio of internal to external diameter, that is d by d naught, which is equal to 3 by 4, which will be equal to 0.75. The rigidity modulus G is 84 GPa, which will be equal to 84 into 10 to the power of 3 Newton per mm square. So L is given, which is 3 meters, which is 3 into 10 to the power of 3 mm, which will be equal to 3000 mm. So we need to find out the diameter of the shaft. So what is the power transmitted by the shaft? Capital N will be given by 2 pi nt mean divided by 60 into 1000 kilowatt. So therefore, you want to substitute the values capital N as 60, which will be equal to 2 pi into 210 into T mean divided by 60,000, which will be T mean will be equal to, that is the mean torque will be equal to 2728.37 Newton meter, which will be equal to 2728.37 into 10 to the power of 3 Newton mm. So once you get that, so we need to find out the diameter of the hollow shaft. So for that, from the torsional equation based on the strength criterion, which is T by tau will be equal to Jp by R. Therefore, T will be equal to Jp by R into tau will be equal to Zp into tau. So therefore, since it is a hollow shaft, which will be equal to pi by 16 into d naught to the power of 4 minus di to the power of 4 divided by d naught, close the bracket, into tau, which will be, so substitute the values, torque, which is given by 2728.37 into 10 to the power of 3 will be equal to pi by 16 into d naught to the power of 4, you take out the common factor, into 1 minus di to the power of 4 by d naught to the power of 4, the whole, and close the bracket, whole to the entire thing is divided by d naught and close the bracket here into 60. So what happens, again you re-simplify that, 2728.37 into 10 to the power of 3, so that is pi by 16 into d naught cube into 1 minus, the ratio of di by d naught is 0.75 to the power of 4 into 60. So the entire thing, d naught cube, and open the bracket, into 1 minus 0.75 to the power of 4, close the bracket, into 60. The whole thing is multiplied by pi by 16. So therefore, outer diameter of the shaft, which is given by d naught, which is 69.712, which has been calculated. Therefore, inner diameter of the shaft, which is di, will be equal to 0.75 into 69.712, which will be equal to 52.284 mm. Now we are going to take up the angle of twist. So in the angle of twist from the torsional equation based on the rigidity criterion, which will be equal to T by Jp, which will be equal to G into theta by L. So you substitute the torque as 2728.37 into 10 to the power of 3 divided by pi by 32 into 69.712 to the power of 4 minus 52.28 to the power of 4 divided by 32 will be equal to 84 into 10 to the power of 3 into theta by 3000. So substitute the values. Therefore, angle of twist in 3 meters, then theta will be equal to 0.0615 radians. So you convert this into degrees to do that. So 0.0615 into 180 by pi will be equal to 3.52 degrees. So this is how you will be able to uh, calculate the angle of rest and the inner diameter and the outer diameter of the hollow shaft. Thank you.